Hello class, today we're going to process the Exponent Rules Lab, the one that we did yesterday. So I'd like to go over the answers to this Rules Lab and each of the conclusions so that we can complete the assignment. So in this video, I will just go over the lab. In the next video, I'll go over the assignment that I want us to do together. And then you'll have a second assignment to complete on your own for a grade. So in this particular Rules Lab, we started at the beginning. And what I was looking for at the very top is, what does 3 to the 7th mean? And what does it sound like? How do you say it? Well, 3 to the 7th, you write it as 3 to the 7th power, where the 3 actually represents something called the base. Okay, and the 7 is going to be called the exponent. Sometimes we call that the power. Okay, so that's another word that we could use for exponent, because we say that as 3 to the 7th power. Well, the a, if we write it as a to the nth, this is an algebraic representation to allow us to do more than just the 3 and the 7. Okay, in algebra, we want to make a more generic form so that I can use more numbers in the problem. So a to the nth is a generic way of saying any number to any power. Okay, so in this one, the a is still the base and the n is still the exponent. So what numbers do the a and the n stand for? The a stands for the 3 and the n stands for the 7. So what I wanted you to do in this particular lab, it says for rule number 1, it says factors and evaluation. Well, what I wanted you to do is write out the factors and then evaluate. The factors of 5 to the 3rd is just what it means. What does 5 to the 3rd power mean? 5 times 5 times 5. So those are called the factors of the exponent problem. Now, in order to answer that question, to evaluate that question, you'd actually type in 5 to the 3rd power. Well, there's two ways of doing that. One way is to type in 5 times 5 times 5 and hit the enter key, and you get 125. The other way, as we've talked before, is to use the exponent key, which we know is this key right here. Okay? So it's that little exponent key right there, and it puts it up above. So you'll notice that it gives you the 5, and then it puts a little box right there so that you're able to type in the exponent. In this case, we're going to type a 3, hit the enter key, and because I typed it too many times, 5 to the 3rd power, you'll notice we get the same answer of 125. Well, that's what I wanted you to do on each one of those. So you should have ended up with 4 times 4 times 4 times 4 times 4 times 4 for 4 to the 6th power, which would give you an evaluation of 4,096. 7 to the 2nd would be 7 times 7, which is just 49. 2 to the 4th power, which is 4 2s, should give you a value of 16. So now for the conclusion. What I basically want to know is, what does a to the nth mean? Well, a to the nth means a times itself in number of times. Okay, so that's what that means. Okay, so that would be the conclusion on this first one. A times itself in number of times. And that's kind of the generic version of a basic exponent problem. But then we had rule number 2, and you had to do things to the 0th power. So you would come over to the calculator, and you type in 7 exponent 0, enter, and you get 1 as an answer. Interesting. So 3 exponent 0, you get 1 again. And then 529 exponent 0, and you get a 1 again. And then I bet if you do the last one, you get 1 also. So what kind of a conclusion could we come up with for anything to the 0th power? Anything to the 0th, and yes, that is a word, power is always 1. So anything to the 0th is 1. And then we go to the next rule. And the next rule is taking everything to the 1st power. So 6 exponent 1, and you'll notice you get 6 back. 8 exponent 1, notice you get 8 back. And then when you do 65 to the 1st power, you get 65 back. So I bet on the last one, you're going to get 8,934 back. So what could we say about anything to the 1st power? Well, anything to the 1st power is itself. Okay, is itself. Okay, because it's one time. 6 one time is 6. 8 one time is 8. Okay, so all of those are some of the basic exponent rules. Now we get into some of the really fun ones. Okay, now this next one, you'll notice that each one on the left has a negative exponent. Each one on the right has a fraction. Okay, so what I wanted you to do is type these into the calculator and write down exactly what you get. Okay, so when you type in 2 to the negative 4, and you type it in exactly the way you say it, hit enter, you end up with a decimal value, 0.0625. And when you typed in the other one, 1 divided by 2 to the 4th power, you ended up with the same exact answer. So what you find out is on every one of those, you end up with the same exact answer. So when you typed in 5 to the 3rd power, you get 0.008. When you typed 1 over 5 to the 3rd power, you get 0.008. So those must have something to do with each other. 7 to the negative 5th would give you a really long, ugly answer, 5.9499 and a bunch of stuff, e negative 5. Now, if you remember correctly, this e negative 5, it's putting it in scientific notation. So anytime you have more than 3 zeros, like this one's got 2, anytime you got more than 3 zeros, it's going to automatically flip it into scientific notation on the calculator. So when you did the one across from it, you should have come up with the same exact answer, 5.9499 e negative 5. So basically that means that I'm going to be moving that decimal 5 places to the left and add zeros to each one of those. So that's what that number really is. Okay, 2 to the negative 6th power gave you 0.015625, and so on and so forth, all the way down. Now, when you did the fractions, when you did the 1 over 6 to the negative 4, you ended up with 1296. Okay. And then when you did 6 to the 4th, you got the same thing, 1296. And then 1 over 3 to the negative 8 gave you 6,561. And then 1 divided by 2 to the negative 5th gave you 32. And then 64. And then over on the other side, you had the same values. So what could we say about negative exponents? So here's what I want you to say. Okay, I'm going to put a conclusion right here underneath, and then I'm going to write what happens in these little spots right here. Okay, so this is what I want you to write. A negative exponent flips both base and exponent. Now, what do I mean by flip? Well, if you look at this a to the negative n, a to the negative n really became 1 over a to the n, and the negative goes away. Okay, 1 over a to the negative n flips, and it goes to a to the nth power. So that negative exponent, what it really does is it flips the entire exponent expression. So if you've got a negative in the numerator as an exponent, it's going to flip it to the denominator and make it positive. And if it's negative in the denominator, it's going to flip it into the numerator and make it positive. And then you'd evaluate it. Okay, so that's what the negative exponent does. It's a flipper. Okay, that's what I need you to understand about the negative. Okay, now the rest of these are pretty interesting. Okay, where you start actually doing math problems. So in this first one, rule number 5, I wanted you to type in 2 to the 3rd times 2 to the 4th. Now to do that on the calculator, you got to remember 2 exponent 3. Well, right now if I keep typing, it's going to be in that exponent. So I've got to get out of the exponent before I can type anything else. So then I do times 2 exponent 4, and you end up with 128. That's my evaluation. Now what I'm looking for a 1 exponent expression is, if you'll notice in the problem, my bases are the same. So I want to know if I use that same base, what's the single exponent I could put right there in order to get 128 as an answer. And what you find out is that is 7 in this case. Okay, so if you do the next one, 3 to the 2nd times 3 to the 6th, you end up with 19,683 as an answer. Okay, for your 1 exponent expression, you end up with a base of 3 with an exponent of 8. Right? Oh, and I did 9 instead of 8, so that's not 19. Let me go back and look at that real quick. because I typed this in, and I did it to the 9th instead of the 8th. I guess I needed my glasses on whenever I was doing it. So let's try that one. 3 exponent 2, right arrow, times 3 exponent 6, enter, and it's really 6,561, which is 3 to the 8th power. So sorry about that. Okay, now 7 to the 5th times 7 to the negative 3rd, you should have come up with 49 and ended up with 7 to the 2nd power. And on the last one, 8 to the 3rd, which gives you an answer of 512. So what are we doing here? Now, what I really want to know about for your conclusion is how do I create this one exponent expression? Okay, so that's what I'm looking for. So your conclusion is, if you have a problem like this, you're going to keep the base, and add your exponents. That's what we're looking for. Keep the base, add your exponents. Rule number 6, instead of multiplying, you're now doing division. Okay, so to type this one in, you would do 2 exponent 4, right arrow, divided by 2 exponent 3, enter, and you find out that the answer is just 2. So how could I write that as a one exponent expression? Just 2 to the 1st power. Okay, now if you do 3 to the 7th divided by 3 to the 4th, you end up with 27. Now, how do we do that? Well, the one exponent expression would be 3 to the 3rd power. Okay, now this next one gives you kind of a weird answer. Okay, if you do 6 to the 2nd divided by 6 to the 3rd, you actually end up with 0.16 with a bar on the 6. Okay, which is, if you kind of pay attention to what's going on, 6 to the negative 1. Or we know that this decimal, because of the fraction to decimals that we're learning, is just 1 over 6. Okay, so if you pay real close attention, this 6 to the negative 1, if we were to go back to rule number 4, what is that negative exponent going to do right here? That negative exponent is going to flip it to the bottom. Okay, so if you look at that one, this negative exponent, 6 to the negative 1, becomes 1 over 6 to the 1st power, or just 1 over 6. Okay, now 9 to the negative 2nd divided by 9 to the negative 3 actually gives you 9 as an answer, or 9 to the 1st power. Okay, so what are we doing with these exponents? Well, looks like we are, instead of adding the exponents like we did in the previous, we would subtract. And that kind of makes sense because multiply and divide are opposites, so is add and subtract. So if you have a division problem with the bases alike, you're going to keep your base and subtract your exponents. Okay, keep the base and add and subtract your exponents. Okay? Rule number 7. What if you have an exponent raised to an exponent? Well, when you evaluated this first one, 3 to the 5th to the 2nd, because you type it in like this, parenthesis, 3, exponent, 5, right arrow, close parenthesis, exponent, 2, hit enter, you end up with 59,049. On the next one, you'll end up with 4,096. On the next one, you're going to end up with 1e negative 5, which really translates into 0.0001. And the last one, you end up with just 1. Now, what did you come up with for your one exponent expression? Well, I'm hoping you found out that you keep the base and you multiply your exponents. So this would be 3 to the 10th. So if we actually type that in, you get the same answer. So 2 to the 4th to the 3rd would be 2 to the 12th. 10 to the negative 1 to the 5 would give you 10 to the negative 5, which really turns out to be 1 over 10 to the 5th power, because what you're not going to be allowed to do is leave an exponent as a negative unless I ask you to do so. And then the last one, 22 to the 3rd to the 0th, will just be 22 to the 0th when you multiply them together. Okay, so what are we going to say about a conclusion? Okay, if you have an exponent or a base raised to an exponent raised to an exponent, you're going to keep your base and multiply your exponents. And multiply your exponents. Okay, rule number 8. Now this one's a little bit different because you'll notice that the exponents are the same, but your bases are different. So if you type this one in, the first one, 3 exponent 2, right arrow, times 4 exponent 2, enter, you end up with 144. So this one I said, for the one exponent expression, you're going to keep the thing that's alike. Okay, so my bases are different, but my exponent's alike. So what will my one exponent expression be? Hopefully you came up with 12 to the second power. Okay, so the next one, you should have come up with a value of 1,000. And then the next one, 9834496. And then the last one, 0.0025. So what would the one exponent expressions for each of those be? You should have come up with 10 to the third, 56 to the fourth, and 20 to the negative second, which would end up being 1 over 20 to the second. So what happens if you have a base raised to an exponent raised to another exponent? Oh, excuse me. I was reading the wrong one there. What happens if you have different bases, but your exponents are alike? Well, you multiply your bases and keep your exponent. So that is the evaluations and all the data for this particular activity, for this data sheet, and all the conclusions. So in the next video, what I'm going to do is we're going to work a little assignment together using these particular rules. So until then, I'll talk to you later.